Physics students, good evening. Mr. Fugit here. We are going to be working through a problem tonight that is going to gear you through or prepare you for one of your homework problems from homework assignment number 1 over density. This is the first video that we're posting, so I'm still getting used to some of the new software that I'm going to be using. Hopefully we'll get more efficient and really better throughout the year, so kind of bear with me as I'm going and utilizing this software as well. Feel free as you're watching to pause, fast forward, slow down, speed up, rewind, depending on how comfortable you are feeling. As always, if you run into any questions as you're reading through the problem or watching the video, don't hesitate to send me a message, an email, or a mind message. I'm happy to answer any questions that you have. The problem that we're going to be working on here in this video is geared towards problem number 5 on your homework assignment number 1 titled Density. This problem specifically is Density 000A. So I will read our problem statement for us and we will see what we're trying to look for here. So our problem statement says this: a copper rod has a height of 3.2 centimeters. As I read, I'm just going to go ahead and make a note of these values as we go. My height, h, is 3.2 centimeters, cm. Okay? And we also are given a mass of 482.548 grams. I'll make a note of that as well. Mass is 482.548 grams. Okay? The density of copper is 8.96 grams per cubic centimeter, or centimeter cubed. So density, rho, is 8.96 grams per cubic centimeter. Not the best M, but we can work with it. And I'm asked here, what is the radius of the rod? R equals question mark. We don't know. Okay, so as you work through this problem on your own, you're going to notice your values for the height, your values for mass, those are going to change. They're going to be different based on your specific problem. Okay, so as we go through, know that I'm solving these values for my answers, but if you follow along, you should see the process that is similar for you. So we're given our height, we're given our mass, we're given our radius, we're given our height, mass, and density, and asked to solve for radius. So what I'm going to do is I'm going to open up a new page, okay, and we're going to see if we can take what we're given and try and solve for this radius. So here we are. Well, I'm given initially, if you remember from our problem statement, I'm given a value for density. Okay, well, I know that density, we'll call that density as rho, is my relationship of mass to volume. So if I look at my equation for density, it relates those values, mass and volume. Now what I don't see is I don't see my variable for radius, r. I don't see it anywhere there. Okay, so you might be thinking, well, where do I go from here? I don't have an equation that is coming to my head right off the top, or coming to my head right off the bat. What can I do? Well, if you remember from our problem statement, we're given a value for density, that 8.96 grams per centimeter cubed. I'm also given a value for my mass, the 482.548 grams. But I don't know what my density is. Okay, let me read the beginning of the problem statement again. It says this: a copper rod has a height of 3.2 centimeters and a mass of 482.548 grams. If you notice what the very beginning of our problem statement says, it mentions this: we're dealing with a copper rod. Now, if you remember from class, what we discussed is that a rod can be really assumed to be the same dimensions and really shape as a cylinder. And what I know about a cylinder is my equation for the volume of a cylinder, V, and then a subscript CYL for cylinder, is equal to pi times the radius of that cylinder squared times the height, h. Now, looking at this equation, we can see there's our variable for radius, r, right here. Okay? If you'll notice, I'm given my value for height, h, and I can maybe even use this equation up here at the top, density is mass over volume, to solve for my volume. And that's where we're going to go here. We're going to use this first equation, okay, I'll call this really number 1, to solve for my volume. Okay, and then once I have that volume, V, I'm going to use this second equation down here, we'll call this equation number 2, to solve for my radius. And that's going to be our process in solving for the radius of our rod. And what you'll notice is that oftentimes in physics, we're not just going to go through one equation or one step to find our desired solution. we oftentimes will have to look at several different steps and equations to find what we're looking for. And here that's going to be our radius. So let's come to a new page. So here we are on our new page. If you remember, we're going to look now at equation number 2, or excuse me, equation number 1, I apologize. Density, rho, is mass divided by volume. Now what we want to do is we want to try and get volume by itself. If you'll notice in our equation as it is, volume right now is kind of mixed up into a fraction. So what I'm going to do to get volume by itself is I'm going to multiply by V on both sides of my equation. What that's going to do is that's going to cancel out my variable for volume on the right-hand side of my equation, okay, and we'll move that variable V over here, if you'll notice, to the left-hand side. So I'm going to rewrite my equation now. Volume times density is equal to mass. Now again, we're not to a point yet where volume is by itself. So here, I'm going to divide both the left-hand and the right-hand side by my variable rho for density. So what this will do is this is going to essentially get rid of my variable rho on the left-hand side and move it to the right. For the sake of space, I'm going to erase what's now here, and I'm going to move my variable V for volume over. So we should now have an equation that looks like this. Volume is equal to mass over density. And I simply got there by multiplying by V and then dividing by rho. So what I'm going to do now is I'm going to plug in the values that I was given for both mass and density. Okay, and they look like this. Volume V is my mass, which according to my problem statement was the 482.548 grams, and I will divide that by my given density, which was 8.96. This will be a little bit tricky here. Grams per centimeter cubed. Okay. Again, still getting used to the writing. Sorry for things being a little bit sloppy there. So now that I have these two values, 482.548 divided by 8.96, I'm going to plug them into my calculator. Okay, what that should give me is something that looks like 53.86. So what I'm going to do is I'm going to erase this value now so we can, again, for the sake of space. There we go. And what that will leave me with is a volume for me equal to 53.86 centimeters cubed. And that's our first part. Okay, we've now used what we know about density, mass, and volume to solve for my volume V. In our last step, we're going to take this volume and plug it into our equation for the volume of a cylinder or rod to solve for the radius. Let's come to a new page. So now we're here on our last page. We're going to use equation number 2, if you remember from our second slide. So our equation here is volume for a cylinder is equal to pi times the radius squared times my height, h. Now, just like we did in our previous equation for density, we want to try and set up our equation to where the radius, r, is by itself. Okay? So if I want to get r alone, the first thing I'll notice is that r right now is on the right side multiplied by pi and h. So I'm going to divide by pi and h on both sides of my equation. Okay? This can get a little bit tricky at times dealing with these variables, but follow along and feel free to pause as you need. So this will get rid of h and pi on the right-hand side of my equation, and I'll rewrite our equation now. We have something that looks like r squared is equal to our volume divided by pi times h. I just got there by dividing by pi h on both sides. Now, we're almost to a point where our radius, r, is by itself. But you'll notice I have this tricky exponent up here, r squared. The way that I'm going to get rid of that is by taking the square root on both sides of my equation. So it will look like this. Take the square root on the left side and the square root on the right side. Okay? For the sake of space, what I'm going to do now is the square root of r squared is going to simplify the left-hand side to simply just r. The right-hand side will remain as the square root of volume V over pi times h. So at this point, we now have an equation for our radius r in terms of our volume, v, which we just solved for, divided by pi and our height, which we're given. So hopefully as you've been going, you've been writing down these numbers that we've been calculating. And it's always important to keep track of the numbers that we're solving for as we go, because oftentimes they're going to show up later in our equations. So I'm going to plug in now what I know. My radius, r, is equal to the square root of my volume, which from my previous calculation was 53, that is a 5, I apologize, 0.86 centimeters cubed. All of that divided by pi times my given height, which was 3.2 centimeters. Okay? So my equation should look like r is the square root of volume, v, over pi times h. So when I plug this into my calculator, 53.86 divided by pi divided by 3.2, take just a moment and plug this in. That's going to give me a value for my radius r of 2.31 centimeters. I'll come to a new slide. So my radius r, according to what I saw, was 2.31 centimeters. Okay? Remember, when we plug our values in to your online homework system, our rule for significant figures is 3. So we're always going to round to 3 significant figures. Now, your value for radius is going to be different. You are going to have a different height and a different mass. That is okay. However, your process is going to be the same. We're going to use our first equation for density to solve for volume, and then we're going to use that volume to solve for our radius of our copper rod. So, hopefully that should give you a little bit more direction on where to go for problem number 5. Again, if you have any questions, don't hesitate to contact me, send me an email or a message on Remind, but this should give you a good starting point. Okay? Good luck.